Hi all, welcome to Network Path. The last video we saw how a complete network gets fully converged. Every router knows about every other network, the next hop to reach it, and how many hops are there. That means hop count. But what happens when something changes? In this video, we will see two cases and we'll understand how routers react to those changes. So let's talk about the first case. Case one is network goes down. So any one of these network will go down or get disconnected from the interface. So if network 10.1.5.0 goes down, the solution is very simple. Router D, which is directly connected to that network, will notice this thing. And in its next scheduled update, it marks the route as unreachable, and the same thing will be shared with its neighbors. Okay, very simple. The neighbors then pass that information along, and every other router in the network gets this information, and within some time, network reconverges. So you know that if update timers are fast, then reconvergence gets faster, and if update timers are slow, then it will take more amount of time for reconvergence. So this was a straight away simple case. Let's talk about second case, that is if a router fails. A router fails. Okay. So let's say router D in this case got into some issue. Okay. And this case becomes a bit trickier than the previous one because router A, B, and C still have entries in their tables saying 10.1.5.0 is reachable through router D. But now D is gone and no one is left to tell them that the information is invalid, right? In the first case, it was easy. The router D itself knew that the network is connected or not, and it used to send regular updates. But the router D itself has gone down, so they keep forwarding packets towards D. So if A wants to route some packet to 5.0, it still not has got any update about if 5.0 is alive or not. Okay, and those packets disappear into a black hole because they are going nowhere. Router C will forward those packets to D, but we know that this router is failed now, so all these packets are going to get dropped, right? So to tackle this case, okay, to tackle this thing, to solve this issue, distance vector protocols use a route invalidation timer. Okay, what we call it? Route invalidation timer. We can call it route aging as well. So what it does, when router C first learns about 5.0 from D, it sets a timer for that route. Okay, let's say if I got one route, I'm a router and I got one route from my neighbor, I will set an route invalidation timer or route aging timer to, let's say, 50 seconds. And every time I hear an update from that router that 5.0 is there information about 5.0, I will reset that timer. Okay, let's say I got an information about 5.0 from router D. I will keep it, and my route invalidation timer will run in the reverse direction, let's say 50, 49, unless and until I get a new update from any of my neighbor. And if D goes down, C stops. I will stop hearing about those update, and eventually the timer will expire, right? So in this case, if uh, C was getting these routes, and if D goes down, C stops to hear those updates, right? And the route invalidation timer for C will eventually expire. What And when this happens, C marks the route as unreachable and tell its neighbor in the next update. Right? C C is running, C in this case is running two timers. One is its update timer, and second is route invalidation timer. So upon update timer, it sends update, and upon expiration of the you know uh, uh, route invalidation timer for a specific route, it will remove that route or it will make it unreachable. Okay, so this is how routers get to know that this route is unreachable, or it is we are not able to reach out to it. Okay, the timeout isn't very immediate. Okay, so there is a twist. So if you, let's say, we set the route invalidation timer for router C as 5 seconds. Okay, 5 seconds, or maybe let's say 2 seconds. Okay, 2 seconds, and 1.0 got failed, and A was sending that information to router C, and on the way, the packet got lost, maybe because of the overload on this link. It might have got dropped, but because our, you know router C's route invalidation timer is just for 2 seconds, it will reset itself to 0 and will mark in the table that route 1 the network 1.0 is now not reachable and is unavailable. Okay, so this is one of the problems when you set route invalidation timer or aging timer very low. And if you, make this uh, invalidation timer very large, let's say 50 seconds or 100 seconds, it will take a lot of time and reconvergence maybe, right? So it is not going to update those things very quickly, right? So too short, if the timer is too short, and you might, throw away a perfectly good route just because one update was lost in transit. And if you, make it too long, the convergence will, drag more, leaving black holes in the network. So protocols strike a balance between responsiveness and stability, and that's the trade-off. Okay. I hope this concept about route aging was clear to you all. If you have any doubt, you can write down in the comment section and I'll clear that. Okay, so this was it for this video. Thank you so much.